Okay. Uh, Three very important applications today of Hive. One, how to create a UDF, user defined function in Hive. And the second is how you use JDBC with Hive, which will open you to the entire world of reporting and applications or web applications, anything. So tomorrow you want to write a web application and you want to connect to Hive, what you will do? JDBC, right? You want to create a report and you want to write a pie chart or something that you want to create, you can use the same thing. And once you know JDBC, you can explore yourself if you want how you can connect R through JDBC to Hive. That's why it's opening up the entire possibilities of how you integrate your Hive data source, right? And third, I will use one of your machines, Windows machines, with Excel for showing how you connect Excel with Hive. So that shows you the entire world of Hive, right? I don't think anywhere it is discussed in a capsule like this. So let's start with UDF, okay? There are so many steps. So that recording you hear, otherwise you will definitely make mistake. The jar files, you should be very careful how you are using the things. The version should be very careful. You are not going to get it otherwise, and you will be troubleshooting a lot. Okay, so I have encapsulated everything. So you have to make sure that when you are doing this, you are using the correct jar files. The version is very important. So look at this. Let's start with Hive UDF. Okay, what is UDF? User defined function. What is meant by a user defined function? For example, let's assume that you have a school name inside your My Schools table that we created yesterday. I hope you didn't drop it, right? So assume that in the Hive prompt, I want to write all the school names in caps lock. I want to print it, okay? So I want to write select, okay? I want to create this function as my uppercase or my upper. I am writing that function. In bracket, I am going to write school name from my schools. So look at the way. And if you type this on the Hive prompt, I will show you, you will get an error. What is error you are going to get? My upper, I don't know, right? So what we are going to do, we are going to write a function called my upper, register to Hive, and then allow all the users to use it. What's the advantage? When you are working, reusability. When you are working on certain projects, let's assume that a claim number, you want to truncate and take only after the word Q or M, whatever is coming up. You want to take that one. Otherwise, let's assume that you are working on a credit card number and you want to mask that credit card number so that nobody is understanding what actually the credit card number is. You want to do the encryption of that particular credit card number, right? So you will write custom functions in your organization and you will register those custom functions onto your Hive environment. And then you will publish it to the outside world telling that, hello, I have created this particular function. Whenever you want to use this particular one, okay? There is a beautiful architecture coming up by Amazon. It is not approved for internal data and all. It's called Amazon Comprehend Medical. This is a beautiful package that Amazon is creating on AWS, Amazon Web Services, to handle almost all medical applications, including machine learning, artificial intelligence, claims processing, care management, etc., right? The whole problem is that if suppose you have data in your company, let's say ABC is your company and you have got your healthcare data, this is HIPAA and you cannot share this particular data with anybody. So you may write a beautiful Hive UDF or a function which takes this data, encrypt it or mask it before you give to AWS. and then you do all your analytics and algorithms and everything, and then you get back and you convert back using another Hive function back to your data. There are millions of applications that are going to come using this kind of architecture in the future. That is the future, right? Whether it is a bank, whether it is a healthcare company, whether it is anything related with the data, that data can be masked and send it, and then you will use the cloud environment for all your architectures. This is the future. In the next 5 to 10 years, this is what you are going to see in the entire world. Okay? There will be lots and lots of projects. And now, the latest things that are going to come, maybe you might be using an Azure service instead of Amazon, or maybe using Google service instead of Amazon. You may be using one service from here, one service from here, one service from here. You need to send the data, and then you will get back that particular data, and that data will be there. And you will pay only for what you use. That is the advantage of cloud, correct? And there are serverless architectures coming in the cloud, which is also called as a Lambda architecture. The Lambda architecture is allowing you to run your service on some machines and destroy that machines after you run the service. That's called serverless computing. And that is going to be the next future. So these are all what is happening in the technology. So the fundamental is how you mask your data, or how you create your user-defined function, right? So let's see how you are going to do that. First, what you need to do is how to make it full screen. This one, right? Okay. So please go to the browser and go to foroursun.com, right? /passion, and download the file called myudf.jar. You will see it a little bit below. Here is that myudf.tar. Sorry, myudf.tar. Did you find it? Yeah. myudf.tar, and click on that. As you can see here, click and save it into downloads. myudf.tar. Once you have it, open the terminal. Make sure your MapReduce lib is already available there. Remember MapReduce lib? Yeah. All the jar files we have kept on the very first day of our class, right? Whatever is needed for your programs. And you have got your passion bytes as well, where your concepts 1, concept 2, everything is there. First, what I'm going to do is I'm going to bring that myudf.tar to here. How will you do that? Move, downloads, myudf.tar to here. I have copied, as you can see, and then tar xvf. It will create a directory called myudf in your home directory, as you can see. All clear? So you have moved it and you have untarred it. Tar xvf on that myudf.tar, and you got that particular data, right? You should do it after copying it. Otherwise, it will give you an error. See, I moved it first to the current directory, and then I have untarred it. All right. After I'm doing it, I'm going to go to myudf. And look at that. There is a build.xml, and that is a problem. Why? That build.xml is coming from passion bytes. You need to change that build.xml to point to your MapReduce lib. How will you do that? vi build.xml, and in the build.xml, instead of this particular line, file set directory map base directory /lib, I am deleting it, and I am going to write /home /cloudera map reduce lib. Very, very important. Why? Because that is the directory where all my Hadoop jar files have kept. Right? In the build.xml. And you can see if you drag below that I am creating a file called myudf.jar inside the build.xml. Do you remember in our Hadoop code examples, we always created myhadoop.jar? In the similar way, now we are creating myudf.jar. So I'm not changing it. So what is the only change that you need to make? The reference to your MapReduce lib. And then let's understand what is happening in, cdcom, cdpassion. So what is the package name? What is the package name? com.passion is the package name. Remember all these things, right? And inside ls, I have another directory, UDF. So tell me what is the complete package name? com.passion.udf. And if you look at ls, you can see there is a program that I have written which is in Java. So what's that indicates? If you want to write a UDF, you should write a Java code. What did you do when you wanted to write a partitioner? You created a Java program extending the partitioner class of Hadoop. Remember? In the similar way, if you look at myupper.java, you can see that you should extend a UDF class provided by Hadoop. And when I say provided by Hadoop, where are all those jar files kept? In the MapReduce lib. That's why you made a reference. Already we made a reference, correct? And inside that myUDF, I am telling that whatever parameter you are giving, this is called a parameter. Whenever a function is taking something, it is called a parameter, correct? The parameter is coming, just return null if the parameter is null. So if the school name is null, will you convert it into uppercase? No, it will just be null. Otherwise, you are going to convert it into uppercase. I just wrote it for fun. If you want to add your name or something like that. For example, here I just wrote Percipient, so I'm just changing it to, let's say, Passion Bytes, right? What will happen? Whenever you are giving a school name, it will prepend that school name with a Passion Bytes colon. Just to show you how you can manipulate. That is actually not needed. I just wanted to convert it into uppercase, but to show you what all magic you can do. So if you are good in Java, if you know how to use random numbers, if you know how to shuffle the strings, what you can write here the code. Shuffle the school name. What will happen? The school name will become completely jumbled. Is it not what you want for masking the data? But one very important thing. What is masked and what you got, you should store somewhere. Otherwise, what will happen? When you get back, you don't know what is this standing for. That you can store in another CSV file and load it into another Hive table if you are intelligent. Correct? That's how the enterprise or organizations work. So you can do whatever you want to do in Java by taking that particular parameter. You can use a private key and you can encrypt that complete data so that nobody can even decrypt it. Right?
Is it possible to apply AES algorithm?
Everything, yes, that's all. So you can import the corresponding Java package, AES packages. Just search in Google how to write a small program to do AES encryption in Java. Write that code here. That's it. And you know already, If you are using third-party jar files, what do you need to do? You have to import it here and you have to put that jar file in MapReduce lib. All that we covered, right? In the PDF examples. Right. So, you wrote that UDF and now there are so many steps, okay? And that's what I saw. Yeah. So, come out. First thing that you need to do is compile your code. How? So it will compile and it created a jar file. Look at that jar file it is created. myudf.jar. Where is it created? In dist. Already we know. Now, I am opening another command prompt, just dragging it on this side. I am going to go to the same directory and I kept you one file there, if you observe. Help on udf.txt. That is very important. That is giving you the way of how you are going to register this function into Hive. Now, Hive doesn't know that you wrote a function. How will you do it in Talent? Have you ever written a custom processor in Talent? Rather than using the one which is given by Talent?
No, routines or like routines. You will write in Java.
You will write routines, right? You can write processors in Talent. Custom processor. You can drag it so that your processor will come. How you will do that? You will register it into the lib of Talent. Exactly. So, vi help on udf.txt. So, what you need to do? Please look at this. After writing the code, this is the complete notes for you. After completing the dot, create the jar file. We already did this. Now, the very important thing. How will you register it into the Hive? Anything you want to register into big data should go to the lib folder. So, are you going to send your myudf.jar? You will send to the admin telling that, hey, I have written this one. Can you please put it into the lib folder? That is one approach. But I won't suggest you to do that. Why? The admin is going to get the mail from everybody and he doesn't know what you wrote. Just like somebody has written a code for like last week. Gone. So, it is not a good practice. But sometimes you can do this if it is a very solid method, it is proven, it was using for last 6 months and it is very solid and you want all the enterprise to use it, you can put it in the lib folder. But remember, if you put it in the lib folder, you are permanently changing that Hive's lib folder, correct? When you do a migration to the next version of Hive, you have to make sure that this is also moved. Problems. The other way is temporary. You just register it temporary only for your session, like Java home. And that's what we are going to do. And that is the correct way. Every time when you come, just register it and then temporarily use it. Okay? So, how will you do that? Add jar myudf.jar is the first command that you are going to write. So, please look at this. Okay? Remember, where is your jar file? I am in the other window. Your jar file is where? In the dist folder. That's why I told you, please be careful about the steps. If you are not writing in the dist folder and you are trying to do all these things, it will fail. Then I am starting Hive. Look. I am not starting Hive from any other directory because I want the context of that particular file. So I went to the dist and started Hive. Now Hive has got access to that directory. Now I am going to write add jar. It will not autofill myudf.jar. You cannot write this unless you started Hive from the dist. If everything is okay, what will come?
Added.
It is added. So now you registered to the Hive. What did you register? Your function or your Java code? No. Where did you write function? Java code. You just put Java. So, as I asked you the question, you know what you have to do. What you need to do now? Now you have to give a function name which is pointing to your package that you wrote. See the linking. And what is the package that you wrote? com.passion.udf.myupper. Correct? So, I am going to write that particular line here. See? Create temporary function myupper. And please look, this myupper is completely different from the Java code that you wrote, myupper.java. That you can call it as cat.java or dog.java, no problem. The function name that you give here is what you will write there. Are you clear? All these things. If you write something there and if you use something here and then you try to use myupper, it won't work. See the linking. That's why I gave you the text file. Okay, so I am going to do this thing, create temporary function myupper as this particular one. Sorry. Right. Copy. Where is it? Go to the other window and I am going to write here paste. Again, I said okay. Now you registered it. All right. Control L, clearing the screen. Select myupper. What was the name of the table? My schools or schools? Clear? These are the steps to be followed. Whenever you want to write a UDF, you register the UDF. First you write the code, compile the code, add it to the repository, either permanently or temporary, and then use the temporary function. See how nice it will be that your complex process of taking the data from a particular table, looking up into another particular column, and then you are merging it, and then you are finding out, okay, what is the greater the number or lesser number in this particular thing. Everything you encapsulated into a function and just write that function in that. So, that covers how you will be writing a UDF. Okay? Now, clear? Clear. Next, we look at how you write JDBC. I don't think I have any program here. Hive JDBC, is it there? Don't worry. What I'm going to do is, first I'm going to create some jar files in one directory. Why? We already have MapReduce lib, which contains millions of jar files, correct? Not millions, around thousands of jar files, correct? All Hadoop, everything is there, right? For Hive JDBC, you don't need all that jar files, 1600. No, don't make your code so thick always. You need 7 or 8 of them. So it's a very good practice that only what is needed is used. Another problem is, tomorrow I will tell you, okay, connect from BERT to Hive. If I am telling you 1600 jar files, you will have to add that 1600 jar files into BERT one by one. So always make sure that it is thinner. How will you do that? Look at this. Like MapReduce lib. This is the second part. Okay, first part we have already completed. You are all very clear, right? UDF. Okay. So CD. Forget about my UDF directory now. I am going to create mkdir Hive jars. Maybe if you want, you call it as Hive JDBC jars. Okay. CD. Hive JDBC jars. Now, go here. Help Hive jars help.txt. Please open that file. There is a file. Hive jars help.txt. Click on that. I'm going to make it bigger. Look at that. How many files? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 files. Look at that. We don't need that 1600 files, right? And now be very careful. This is what I told you, everyone. Do not unnecessarily copy this. This is just a hint for you. Why it is a hint? When I used Cloudera 5.15.1 version, this was that. For you, is it 5.15.1? God knows, correct. So for you, you have to use your version. Are you with me? If you type this command and I am not getting anything, you won't get anything. It is different date and it might not be there at all. So this is a hint and I will tell you how to do this. Okay. Look at this. What I am doing this command is very, very familiar to you. What it is doing? It is finding out all the files with Hive JDBC and you are copying all these files, correct? But all these files are there already in our where? MapReduce lib. So what do you need to do? Just to get a hint, okay, there is a file called Hive JDBC. Bring that Hive JDBC from MapReduce lib to my Hive JDBC jar file, correct? Are you following me? So, keep this one. Not move. Move means it will permanently move. Then your MapReduce lib will not work. Okay. So, what I am going to do, I am going to keep this just down, okay? And let us take one by one, okay? So, ignore this command, okay? This particular thing where you will do when you are going to a company for the first time. You don't have MapReduce lib. You want to find out, right? Okay. For us, we have MapReduce lib. So, please look at this, what I am doing. CP. What is this symbol? Home directory / what? Okay. Now, what is the name of this file? Hive-JDBC. Okay. So, please look what I am doing. Hive-JDBC and tab. No, tab. But the star means it will tab. Okay. What did I get? And what is the version number? 5.13. Did you understand now? That's what I told you. But in my case, you see, that was old. It was 5.15.1. So, how many files I need from this? Please tell me. Do I need all these 4 files or I need only these 2? Look at this. 1 and 2. This and standalone, correct? So, I need how many files? 2 files. And both the files are having what? 5.13. So, what I am going to do? hive dash JDBC star 13 star dot jar. That means the files which contains the word 13. 2. So how many files will be copied now? Tell me. Okay, 2 over. Now what is this? Hive exec, hive common, hive metastore. Okay, very good. Hive exec, hive common, hive metastore. But be careful. You took which version? 5.30. So you should make sure that you are taking 5.30. Okay, so how will I do it? Again, MapReduce lib. I am going back here, and what is the name of the file? Hive slash exec. So many are coming. Hive exec core is there. Hive exec dot jar is there. Hive exec core dot jar. No, I don't want any of this. I want only this one, correct? That's why I told you, if you are making a mistake in these jar files, you will not get the output because versions will conflict. So many errors will come. So, copy. And what I'm going to do? Clear? I am going to write that what I copied just now. What I copied? Paste. This is the file I copied. So how many files now? I copied exec also. And what is the next one? Common and metastore. Let's do it quickly. Common, metastore. Okay. So same thing. MapReduce lib and hive. What is that?
Common.
Okay. Hive common dash. Copy. And what is the next one? Metastore, right? Why metastore?
Database. So create the structure method.
And where it will refer to?
MySQL.
Now you know. Hive metastore. What is the file name? See, always it is confusing, very confusing. 2 files are there. You should not use that other file. Oh, sorry. Okay. Hive common completed. What did we?
Execute
Okay.
common metastore complete.
1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Next one is some files. libfb. What is FB? FB. Yeah, correct. Facebook. I told you who created Hive. So there are some files that is given by them. What is the file name? libfb. This is not a problem. There is no 513 or something like that. So let's take this one. Okay. Lib slash copy paste. Okay. What happened?
2 libs.
Huh? Oh yeah. MapReduce lib. There is no lib. See, watch the errors. All right. Next one is log4j, Hive service, log4j. Log4j is very common. You need for logging. And there will be many versions. See, take 1.2.17 dot jar. Done. And what is the next one? After the log4j, we have Hive service, Hive service. See, Hive service, you need which file? Hive service 1.1.0, this one, right? And after the Hive service, we need Hadoop common. look at that. It is not Hive related. Why? Hive is relying on what? Hadoop. So you need Hadoop files. So this, don't take tests. Mistake. This is the file that is needed. Oops. And there is one more. What is that? Comments logging. Last one. Take 1.2, copy, paste, and do an ls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Understand? This is how you should create the jar files for your program. Alright. Once these jar files are available, the next step is you can download a beautiful code which is the duplicate of your favorite code that we did in MongoDB. What did we do in MongoDB as a project? Twitter data we downloaded and put it into MongoDB, correct? What I did is I created the same program, download from the Twitter and put it into Hive. But it is not JSON. I just parsed it and I took only the message. So where is that program available? Go to forwardsend.com/passion and you see Hive Twitter 2.zip. Don't take the old one. There are 2 versions, I think.
It's there.
Yeah. See, Hive Twitter old.zip and Hive Twitter 2.zip. This is the one which we want. Save file. Move. Hive Twitter 2.zip. Unzip. It is a zip file. So Hive Twitter CD, Hive Twitter, you have already Mongo Twitter. And CD code, clean, how will you clean? Aram minus rf, because never use the classes that I gave you, because it will be coming from my version of Java and it will give you error. And you have got source, vi, mytwitter.java, class mytwitter, all my keys are written there. And instead of connecting to first I am writing into a file called myfile.csv. And then I am running that. I am copying that file using SFTP. This you cannot run on the virtual machine. This you have to run from a normal machine where you download the data, SFTP to your Hive, and in Hive it will be stored. That's what you are seeing the code. My SFTP.send myfile.csv. You are doing this in Talent, right? Every day. You are downloading some files and you are getting some files and then you are SFTPing into one directory. That's exactly the program. Okay. Little bit of work is needed. So let me just work on that. So new mysftp.send myfile.csv and that file will be sent to Hive and Hive will be loading that particular data. Right. But that is not showing you Hive JDBC. What we are doing is Hive JDBC. Keep that particular program. We'll come back to that program later. For Hive JDBC, what I would like to do is, I'm going to create copy of this particular code. Where am I now? In Hive tutor directory, I have a code, correct? So I'm going to write a copy of this particular code. How will I create a copy of the code? cp -r code. Okay, -r is recursive, and I'm going to write JDBC code. Okay, cd JDBC code. I don't need my file.csv. I don't need sftp.txt. I'm deleting all these things, making it clean. I have build.xml, vi build.xml. And in the build.xml, it is not dealing with any Twitter data. So I am directly giving my jar file name. Can you tell me what is the jar file name that I am going to give here? /home /cloudera / That's why we created that, my dear friend. This is the beauty of Ant. Why did I create the 10 files? Hive JDBC jar files. And finally, the name of the program that we are going to run is my Hive. We don't need Twitter. So my Hive JDBC.jar. Okay, that is a jar file that will be created. And when I'm running this particular program, I will write and main. Okay, so here I will write and run. Run is my target. See how quickly I'm changing it, because you should be now familiar, right, in build.xml. Okay, I will write here main. So my name of the program should be main. I don't need any of these things. My SFTP I don't need all these things. Okay, now make sure your and is perfect. How will you check it? Just type and duplicate target run. See, it is wrong because I changed it. So there is 2 runs. So I have to remove 1 run. Where is the 2 runs? So there is a zip. There is a run. So I don't need this run. Why? Because below also I gave a run. See, there is a run here. And below also I gave a run. That's why it is giving duplicate. So what I need to do? Comment it out or delete it. How will you delete? dd. Beautiful. No problem. Don't worry about that error. That is code error, but build is correct. And now why you are getting this error? Because there are so many other things inside this source code. I am going to remove all this particular code, right? rm -r of star. No, I'm going to write main. So nothing is there now. And now vi main.java. Did you give any package name in the build.xml? Run. Instead of run, you just wrote main, right? If you give com.passion. Then you have to give com.passion. You should be very clear now. So vi main.java. And what I need to do? Google Hive JDBC client. Press enter. Sorry, spelling mistake. Hive JDBC client. And Hive JDBC clients. Come down. Basic, beeline, all these things are there. Okay, come down. Forget about all these things. When you are just reading JDBC, you will see now that there is a sample program that is given here very nicely, and you just need to copy that particular program and make relevant changes using JDBC. JDBC client sample code, and you have got the sample code completely. But remember, here the class name is Hive JDBC client. But what is my class name? Main. So I have to change it. So what I am going to do, just copy that particular code, right click, copy, and come here. Nothing is there inside my main. Right click, paste, and I need to change this one as now. So many lines are not there. Okay, so here everything is commented. So what I am going to do is I am going to uncomment these lines. Connection CN. I am completely writing the program rather than giving you the pre-cooked program now. See, this is how you should learn the things. Okay. JDBC Hive 2 localhost 10,000 is default Hive. What is that? Anybody? URL JDBC colon MySQL. Remember? But here what you are doing? You are connecting to Hive. And user ID is Hive, password is nothing. And then the next line, you are creating a statement. In JDBC, always, whenever you are creating a connection, you will create a statement. How will you create a statement? This is the line. Statement st equal to connection.create statement. Then what you are going to do? You are going to create a query to a table. But what is your table name? There is no test driver table for us. What is our school table name? And then come here. Statement.execute. Drop table, it is telling. No, I don't want a drop table. What I need is, I need to do a select star from table name, correct? Statement.execute. Select star from, what is my table name? Table name I declared on the top, correct? Table name. Statement.execute. And always this execute will give you a result. And where is the result available? Result set rs equal to statement.execute. Okay. Now, what I am going to do, delete. Sorry. Is execute query. Execute query. Right, and I am going to delete this line. Did he? Delete all the unnecessary stuff. Okay, result set is obtained, and after the result set is obtained, what you need to do? While rs dot next. That means you are iterating through the result set because you got the query result from the database, correct? And what you are going to do inside the rs dot next is you will write here what? System dot out dot print line in bracket. What do you want to print? rs dot get string of 1. What is the first column in your schools? I think the first school nickname or something like that, right? Get string plus just let us put a space or a colon and just write rs dot get string of 2. That's it. So you created result set, connection, all the things that you have created, and finally what you should never forget, connection dot if it is not there, what will happen? You know. Finish. There is a problem in the bracket. Okay, anyway, it will give you compilation error at the time, you will know. Okay, here that class not found exception is not closed, so I will just put a bracket here, and this is a while loop closing. This is your, what is this? What is this? Yeah, this is closing, and this is the method, and this is the main, I think, class main. So let's try our luck. Clear? cd dot and fantastic, success, right? So now you created the JDBC program. Everything I did is scratch in front of you. You should not ever get any doubt in any JDBC program. And now you can type and run. Remember? But before that, you have to make sure that the JDBC is ready to accept connections. How will you do that? Open the another command prompt. In that command prompt, please type Hive server 2 start. What it will do in Cloudera virtual machine, it will make the JDBC connections ready at that particular port. Leave it after running that, okay? Don't close that window. Hive server 2 start, and now let us try and run. Could not load the main class. So there is vi source main.java. What happened? Public class main, public static void main. What is the error that I got? Could not find or load the main class main. Okay, so
Capture layer again, small layer.
what's that?
Class name is small MAN.
Ah, very good catch. What?
Class. Public class main. The folder we have created is
Huh? Folder is what? Main. ls. Wait. cd lib.
build.
Okay.
In build.xml.
That might be the
Build.xml we have given small.
right. rm minus rf. cd dot rm minus rf lib. Why I don't need this lib directory? Because I am referring to
Java.
Hive, yes. Okay. So vi build.xml. And in the build.xml, what did you say?
Small main.
I don't need this mysftp target also. Main. What are you saying? I know.
Yeah.
That is the problem. The problem is you are not referring to the correct jar file. I changed this jar file as
Hive.
what is that?
Hive
Hive JDBC or
Hive
something. Wait.
yeah.
What is the name of the jar file that I gave here? This is called troubleshooting. My Hive JDBC.jar.
Yeah.
So it is referring to some other jar file, and it is telling that hey, I am not able to find out that particular one. So my Hive JDBC.jar is the my Hive JDBC. Is that correct? My Hive JDBC.jar. Look here, my
Yeah.
Hive JDBC.jar. Okay, clear. And now and. No, one more place where we need to change is, I think it is referring to my base directory / lib. I changed it in the beginning, but I didn't change it here. So what I need to do? Home / Cloudera / what is that? Hive JDBC
Jars.
jars. Build successful. What is it? It connected to Hive and it got all your
Data.
data. I created two columns, right? rs dot get string of 1 and get string of 2.
So place.
Have fun, that's it. And next, just to give you a little bit more excited, what we can do is, where is your but? Where is the but? Huh?
Eclipse.
Where is the but, man? CD MongoDB reporting ls. Okay. Before that, to start but, what I need to do? You will not. You have to. Slom slash cloudera slash jdk8 and then export path equal to dollar java underscore home slash bin colon dollar path and then java minus version. Good. cd MongoDB reporting. Clear. And cd eclipse ls. Already it is Java 1.8 Eclipse. No mistakes. Workspace 1. Window, perspective, open perspective, other, report design. Okay. File, new, project, business intelligence reporting project, report project. Next, Hive sample, finish. File, new, report, attach that report to Hive sample. Give a name here as Hive report example. Next, select symbol listing. Finish. Data sources. We selected MongoDB. This time new data source. JDBC data source. And I'm going to give a name here. Data source 1. Click next. Driver class. I don't know. So manage drivers. And jar files. Add. I am going to go to home slash Cloudera. Hive JDBC jars. Selecting all the 10. Click OK. And click OK. It will take a while because there are 10 jar files which are now getting registered into Eclipse JDBC. And that's the reason why I created it as a separate folder. Now if I select a driver, automatically it is telling me Hive is available. And the database URL. Go back to your program. In the URL it is written that it is JDBC localhost 10,000. Make sure your Hive server 2 is running. Copy. And come back to Eclipse. The URL I am going to paste here, which I copied from my program. Username is Hive, password nothing. Test connection. Connection successful. Click. Finish. And now create a new dataset. New dataset. And give a name dataset 1. Click next. Default my schools. And I am going to write here select school name, comma, school, city from my schools, no semicolon. And click on finish. School name and school city came. Click OK. and then drag the school name here and drag the school city or whatever here, and then go to window, go to preferences, go to general, go to browser, select new web browser, browse, where is it? Select this thing. Okay, file system. Where is it? User slash local. User slash. I think it is in local. Firefox. Got it. Firefox. Click Firefox and give a name Firefox. I told you this is a problem in Eclipse. And click OK. Now I am selecting Firefox as my this one. And click Apply. And then click OK. And then view the report. There is nothing more in big data, man. Nobody does this. This is life. Writing a MapReduce program, creating the data into Hive, and now you know how to write a UDF, now you know how to add the report, now you know how to write a JDBC. Spend time. This is how you should enjoy. All right. So